Alright, let's look at Jamb 2003 question 26. Which of the following chlorides would exhibit the least ionic character? Which of the following chlorides would exhibit the least ionic character? A. Lithium chloride, B. Magnesium chloride, C. Calcium chloride, and D, we have aluminium chloride. Now, to answer this question, the first thing that comes to mind should be the ionic chloride. Ionic character spoken about. Ionic character spoken about. So, you need to cast your mind back to types of substances, ionic substances, covalent substances, and substances of intermediate character. You have your macromolecules, and you also need to remember the characteristics of each of these substances. Very, very important to remember the characteristics of each of these substances. So, if you take lithium chloride, the first thing you ask yourself, all these compounds, what are the constituent elements in the compound? Lithium chloride, which is the first one here, contains lithium and chlorine. And of course, you know that lithium is a metal, chlorine is a non-metal. So, when a metal combines with a non-metal, what kind of compounds will be formed? Ionic compounds. But we have a bit of challenge here. All the options that we have here, we have metals combining with non-metals. And in fact, if you look at it, the non-metallic element part of it, it's the same, chlorine, for all of them. Chlorine is a non-metallic element for all of them, the same. So you will want to ask yourself, what do I need to do next, or what do I have to do next? And that's a very important question to ask. So if chlorine is common to all the options, forming compounds with different metals here, then the solution to this problem can be arrived at when you arrange all the metals and decide to look at the metals in order of their metallic character. So we have magnesium, we have lithium, we have calcium, and we have aluminium. So you have your magnesium, okay, and of course you have your aluminium. Now, using your knowledge of the periodic table, you will find out that lithium is in group 1, magnesium is in group 2, aluminium is in group 3, calcium is in group 2, but it's far lower than what? Than magnesium in the periodic table. So cast your mind also back to how the trend in metallic character changes in the periodic table. So if in the periodic table, as you move down the group in the periodic table, there is an increase in metallic character as you move from top to bottom. Now, as you move from left to right in the periodic table, there is a decrease in metallic character. Now, I repeat that again. As you move from top to bottom in the periodic table, there is an increase in metallic character. As you move from left to right in the periodic table, there is a decrease in metallic character. So, if you have two compounds to compare, if you have two metals to compare, the metals that falls on the left hand side of another metal in the periodic table will have a lesser metallic character. So if the two metals, for example, let's assume we have, let me use C here, coordinate, let me use A here, Okay, and let me use B here. Okay, very good. Now C and A in the periodic table. If C is in group 1 and A is in group 2, definitely the element that is in group 1 will have more metallic character than the one in group 1 in group 2. So A, which is on the left of C, is an element with a lesser metallic what character. Now compare B to C. B is on top of C. So as you move down from B to C, the metallic character increases. So you would expect that if B combines with a chloride and C also combines with a chloride, because C has a stronger metallic character than B, C chloride will have more ionic character than B chloride. So in the same light, if C and A individually combine with a chloride, so that you have C chloride and A chloride, because A is an element of a lesser metallic character, you would expect A chloride to have lesser ionic character than what? Than C chloride. So bringing it home, lithium is a group 1, so you would expect lithium to have a stronger ionic character. Calcium is in group 2, magnesium is in group 2, but magnesium is higher in the periodic table, not in the reactivity series, in the periodic table than calcium. So we would expect calcium to have a stronger metallic character than what? Than magnesium. But aluminium is in group 3, even though aluminium is in period 2, is in group 3 and in period 2. Group 3 and in period 2. So combining everything together, you'll find out that aluminium is more on the left hand than every other element here in the periodic table. So aluminium combining with chlorine to form aluminium chloride will form a compound of lesser ionic character. So the strength of the metal, in essence, the strength of the metal determines the ionic character of the compound that results when the metal react with certain non-metal. So this question, it's basically on bonding, so you need to understand how ionic compounds are formed and the factors that affect the properties of the ionic compound. I hope I have been able to explain this very simplified for you. I'll see you in my next video. Just ensure that you share, you like and subscribe to my YouTube video. Thank you.